Okay, I just recorded an 8-minute video without realizing the microphone was off. Okay, we are on. We are going. Okay. So, this exercise has a look at hyperbolas. Now, you're going to find out what a hyperbola is in a minute, but what we're essentially doing is we're looking at the equation y equals some kind of number on x. And we're seeing what that looks like, and we're seeing the effect of changing that number on top. So, let's do the equation y equals 1 on x, because that seems like a nice place to start. If I were to do a table of values, so if I have x here and y here, and I want to sub in a whole bunch of values for x and see what I get for y, and then I want to graph it. So, yeah, these never look nice. Why don't I go -4, -3, -2, -1. I also want to see what happens when it gets really small, so I'm going to do -1/2. I could do -1/4, I'm not that motivated. 0, and now I want to do all the positives of these as well. 1/2, 1, 2, 3, 4. Let me grab my red pen and fix this, otherwise I won't like it. So you can chuck these in your calculator, but obviously if I've got y equals -1 over -4, that's going to come out as 1/4, 1/3, 1/2, 1 over 1. Now, if I've got -1, oh, no, I'm doing +1 over -1/4, so all of these will be negative. Gosh, my brain's turned off. 1 over -1/2. I want to remind you that that's the same as 1 divided by -1/2, which is the same as 1 times -2 on 1, so it's -2. If I do 1 over 0, can I do 1 over 0? Is that a thing? That's not a thing. Cut. We don't get a value there, and I'll show you what happens. If I do 1 over +1/2, well, that's going to be 2, 1, 1/2, 1/3, 1/4. So if I were to sketch that, okay. And let's say I want to go up in halves, because I really want to see what happens. 1/2, 1, 2, 3, 4, -1/2, -1, -2, -3, -4. Y goes all the way up to 2. It goes 1/2 and 1/3. Okay. So what if I do 1/2, 1, 2, -1/2, -1, -2. Okay. So when x is -4, y is -1/4. I'm going to do this in another color, which is here. When y is -3, when x is -3, y is -1/3, which would be like there. Then I've got -1/2, then I've got -1, and then I've got -2. Okay. And then on this side, I've got 2, 1, 1/2, 1/3, 1/4. And I want to graph these. Now, I'm not going to wonder what happens at x equals 0. Like, I'm not going to worry about that. These, I'm just going to join the lines I have. And what's going to happen is this one is going to get closer and closer and closer to 0. But it's never going to reach there, because the y value can't be 0. It doesn't matter what I divide 1 by, so 1 divided by 100 million, it's still not going to come out as exactly 0. And here, I can divide it by smaller and smaller numbers, but I can't divide it by 0, so this one's never going to touch 0 as well. It's just going to get close. Up here, I have something similar happening. It's going to go up. Oh, sorry. It's going to go up if I draw it right, and get closer and closer and closer and closer and closer to 0, but it's never going to get there. And it's going to go along and go closer and closer and closer to 0. And let me show you on GeoGebra what that looks like. Okay. No, delete those. Okay, so if I have What is... Where? This is frustrating. I was so prepared. Okay. What? Oh, it's disappeared. Okay, sorry. You're probably sitting there being like, Miss Grants is just down there. Press it, press it! 1 over x. Okay. That looks like that. And you can see if I zoom out and out and out, kind of almost looks like it's a cross, like, you know, a T across. But when you get closer to 1, it kind of hits them like there. Doesn't matter how big I go, like here at 1,000, it still won't have touched the x-axis. It will have just gotten really, really close. See how much I'm zooming in? Yeah, and it still hasn't actually touched the x-axis. That's called an asymptote. A friend of mine used to call them asymptotes. And something similar will happen down here. Come on. Okay, whatever. This thing's not a fan of me at the moment. So that means we have an asymptote at x equals 0. We also have one, because we can't put 0 on the fraction, on the bottom of a fraction, we also have one at y equals 0, because it doesn't matter what I divide that top number by, I'm never going to get 0 as my answer. If we then looked at the domain, and we go back to this GeoGebra one, are there any numbers that x can't be? The only number that x can't be, the only number that won't get crossed for x on this graph, is x equals 0. It cannot equal 0, but it can be everything else. With the range, it's really similar for the y as well. So y can't be 0, but it will come out as everything else. If I change the number on top of x, so for example, instead of 1 on x, maybe I want to go, come on, just let me, okay. Oh, it is not responding to anything. Come on, that's so annoying. Sorry about this waste of time, guys. Okay, delete, get rid of you. Oh, it's, okay. No, sorry, not x equals, y equals, maybe this time I want to do, okay, so I'll put in 1 on x so we can compare. Okay, and this one, maybe I'll do y equals a big number, 9 on x. So it'll follow kind of the same shape, it'll just be further away from the x and y axes, so it won't cut as sharp a corner. What if I then wanted to do y equals, you know, 0.3 on x? Then that cuts closer to the x and y axes than just y equals 1 on x. What if, instead of 1 on x, I wanted to do minus 1 on x? Come on, let me type. Okay, maybe not. Y, no? Oh, come on. Oh, I need another beverage. Come on. So I've got y equals 1 on x. And what if I tried y equals negative 1 on x? It's the exact same graph, but it's kind of, it's called what we'd say it's reflected in the x equals y plane. It's just switched around. So this time, instead of being, you know, bottom left and top right, so first and third quadrants. This time it's second and fourth quadrant.